All right. So the first thing that I'm going to show today is a new function in REDCap. It was I don't know when it was released, but it was fairly recent, uh, probably within the 14.0 or above, and it's called the Modulo Operator. So let's get into it. I created a little project here just to demo this. First, I'm going to give you some background on what the modulo operator is in case you're not familiar with it. What it does is it returns the remainder of a division equation. And so for base 10 numbers, it would be the units digit if you divide by 10. So for example, 25 mod 10 would be 5 because 10 goes into 25 two times completely, and then there's a remainder of 5 left over. So that's kind of the easiest way to think about it. It's a weird concept to wrap your head around because it's easy when you think about, oh, it's just a remainder, but it's not the complete quotient of a division problem. It's just the remainder. So it's good for whenever you have things that have a group and you need to see where they fall within that group. So I just created this little project to just show you something. So I'm just getting a random number here. And we want to know if it's divisible by another random number. And so you can see here in the quotient that there's a decimal place afterwards. And so if you wanted to figure out what that remainder was, that 0.6, what does that equal? You would use the mod function. So down here, you can see that 53,684 goes into that other giant number, 10,943 times completely. And then there's a remainder of 32,229. So just to give you maybe a simpler problem there, let's do like 24 into 100. So 24 goes into 100 4 times equally and then has 4 left over. And you can see here down on the bottom, this is just checking my math. So 100 mod 4, or sorry, 100 mod 24 equals 4. And then 4 times 24 plus 4 is 100. So 4 times 24 is 96, and then plus 4 is 100. So it's a way to think about, for example, if we had a cycle of, like, if this number was 256 and we wanted a base 10. So it's a cycle of 10 numbers. So it's going to start at 0. The way our numbering system starts at 0, goes all the way to 9. You get to 10. The units number goes back to 0. And then you have the tens digit. So if you think about it, it's just going 0 to 9, 0 to 9, 0 to 9, even though it's in a base 10 number, it's counting upwards. But when you're using the mod function, it's just cycling within that, whatever you set the base for the mod function to be. Anybody who's in computers knows, binary. So 0, 1 is the cycle, and then when it hits to 2, that's the 10, and it goes back to 0. So now that this function's here, I'm going to show you how it's done in the project here. So let me go to the designer. So here I just have the basic, this is the dividend, this is the big number, what I'm dividing by, and then what the answer is. The quotient is where I have the quotient modulo here is where I have the full number, and I'm just rounding down. So it's taking anything, I'm just forcing it. It's basically a floor function. It's forcing it to if there's any remainder, I just want the whole number. So an easy way to do that is to just wrap your function in the round down function and say you want 0 decimal points. That'll give you the whole integer number for that value. So the modulo, all you're doing is you're going to take the number that you want to divide and then what you're dividing by, and you're wrapping it in this mod function. And while we're in here, I can just show you where the mod function is. If you want to read the description, it's a new function because it wasn't here a while back because there was another project that I needed it for, and I ended up having to kind of finagle a way to do it. But you can see here that it just returns the remainder, and then both values must be integers because mod doesn't work with anything, any decimal points. So if you have 10 mod 4, the way this is written here, the result will be 2 because 2 is the remainder of 10 divided by 4.
Actually, it was added in August last year, although we never look at these things very closely. Like, we get busy, so we can't like present everything that comes out right away. So we're just catching up.
All right. Better late than never, I guess. So
Yeah.
So that's all you have to do for the mod is to use the mod function. Is just have a field that you're going to have as your dividend and then what you're dividing it by. And that's it. The funny thing is I actually stumbled upon this because I was looking at, because REDCap is built with PHP, and PHP actually uses a mod function like dividend, and it's a percent sign. Nope, that's not the percent sign. There we go. And like this. So if you did your math equation like that in PHP, that is the same as doing it this way. And oddly enough, this will say that it doesn't work. Let me just hold on real quick. Let me copy that so I can put it back. It'll say that it's an invalid. It'll go away. There we go. It'll say that there's an error in syntax, but it was actually working for me when I tried it. It says here there's a calculation error. But if we go back to our example and we do 256 by 10, it works. So I saw that it was working, and that's what made me go to the special functions here, because I thought, oh, maybe they added it. And then I, did control find for the mod, and then I saw that they added it, but that it was in a different format. So that's what made me think this would be a good demo to do since it's new. So you're probably thinking that's all, fine and well, but what am I going to use this for? Why would anybody ever use this? So I came up with a couple of examples. One would be, and this was actually the reason, the thing that I had to program in a different way for a different project, is trying to find the day of a week for a given date. And I mean, it's trivial on here because you have obviously today is Thursday, and we have the calendar here. So if I was to just pick a random date, obviously it's Tuesday because I picked it and you could see it. But if you were just getting that date, if you were importing that date from somewhere and you weren't entering it, and you didn't have the today button or the calendar date picker, you'd have no idea. You'd have to figure it out yourself. So this is a good way to use this function, is because basically what I'm doing is my mod, I'm dividing by 7. So I just want to know how many days there are I'm using the date difference function, and then I'm using the mod by 7. So this is the format that I'm using. And I could have you can break this out into multiple steps if you want. You can have a field that just has the date diff function here, and then you can have another field that divides it by 7. and you can get the number and that kind of thing. Because like what I could do is I could do the date diff, and then I could do the mod of the date of however many days there were, and then I could do a calculated field. But I'm just doing it all in one. So what I did was I grabbed a date that's well in the past that nobody's ever going to stumble upon. You know, nobody's going to have a birthday that day or any event that day. And December 31st, 1899 just happens to be a Sunday. So what I'm saying is give me the number of days from that day, from the appointment date. I want to know the number of days, and then I'm dividing that by 7 using the mod function. And then I'm saying if the answer to this mod function is 0, then it must be a Sunday because it comes around full circle. If it's a 1, then that's a Monday. If it's a 2, then it's a Tuesday, 3 Wednesday, 4 Thursday, 5 Friday, 6 Saturday. 7 comes back around to 1 on a Sunday. So no matter what day I put in for the appointment date, it's going to calculate the date difference and divide it by 7 and then let me know what the remainder is. Because if there's exactly, like we go back to the first one here. So let's say there's 49 days between the date diff and or the target date and the source date. You can see here that 49 mod 7, because 7 goes into 49 equally, then there's a 0. And if it's 50, then it's 1. So that would be 7 weeks and a day. And if my week is starting on Sunday, it's going to loop all the way around to Sunday. That's going to be 49 days. And then the 50th day is going to be Monday. And so on. So if I have a random appointment, I can know what day it is. So if there's more things you can do with this, because if you know, if you're doing like a patient calendar and they have an appointment that's like 25 days from this date or something like that, or they get their baseline visit is here and they have to be seen within like 30 days from that day. 30 days is not going to be exactly 4 weeks. It's 4 weeks and 2 days. So it's going to shift. But you could also have it to where if 30 days from their initial visit, let's say it's on a Saturday or a Sunday, you can actually do a calculation to say, oh, it's on a Sunday, kick it over to the next day. So give me the following Monday, you know, instead of being like, oh, it's a Sunday. So there's little things that you can do after this. Another thing that you can do is use, you can change the 24-hour clock in REDCap to a 12-hour clock. Because as we saw with the modulo function, a clock it's a cycle. So, you know, when we were talking about base 10 going from 0 to 9 and then back to 0 again, same thing with a clock. It goes from 12 or 0 all the way around to 12, which becomes 0 again. And then around and around and around. So what we're doing is we're just basically dividing by 12. So if I select now as my time, then my appointment time, if I wanted it in 12-hour time format, it's going to give me 1:16 p.m. And this is the string function that I'll put on the screen here. So what I'm doing is, and this one's a little more, it looks like a lot, but it's not really. Right here, I'm just saying that I want to make sure that my appointment time has a value, right? That's the first thing I'm checking. And then if the left 2 digits of my appointment time are less than 12, then I want to do all this. So basically what I'm doing is I'm going to take the left 2 digits of the appointment time, and I'm running the mod function. So this is the dividend, and then this is the divisor, right? So if it's anywhere between 1 to 12, I just want to divide by 12 and get that remainder back for this whole thing. And then This is all wrapped in a concatenation function. So I'm actually concatenating all of this. So I want the time. I'm adding the little colon for the time. And then I'm just getting the right two characters, which are the minutes. And then I'm also appending AM, space AM. So that's what you're seeing here. So, since we're at 1 o'clock in the afternoon, this is if it's greater than 12, then I'm going to do the same thing. I'm going to run the mod function, and it's 1 o'clock in the afternoon is 13 o'clock on 24-hour military time. So it's going to return back a 1. And then I'm just going to build a string function here by giving me the hour, the colon for the time, and then the minutes. And then I'm just going to append PM onto that. So relatively simple, but there's some problems, and I'll show you that here. So if we just grab this little time chooser here, and I'll just put the minutes to 0. If I drag this all the way to the left for midnight, you can probably see the problem. It's 0 AM because my function here is saying that if it's less than 12, give me the mod 12 value. 0 divided by 12 is 0. So it's returning 0 AM. And if I just tick through the hours, and if you watch this over here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you can see here at 12, it breaks, it disappears. But as soon as I go to 1, it kicks over to 1 PM. So 11 AM, nothing, 1 PM. And then it goes all the way over to 11. So the problem with that is my second condition here is if it's greater than 12. So I'm missing 2 values, so to speak. One, I need to accommodate for when the, and let me just paste this in here. So what I want to do is I need to accommodate when the hour of the time, the hour of the appointment time is 0. And what I'm saying is when it's exactly 12 o'clock or exactly 12 on the hour, doesn't matter what the minutes are. If it's 12:01, 12:15, doesn't matter. The important thing is that it's when it's 12 exactly. I want to, or sorry, when it's 0 exactly, which is midnight. I want to just hard code the 12. So I'm giving it the hour instead of running the mod. I'm just giving it the 12. And then I just want the minutes, and then I'm adding AM. Same thing here is when it's 12, so instead of midnight or 0, it's 12 exactly, or 12:01, 12:15, whatever. I'm also giving it the 12. And then I'm giving it the minutes and then PM. So if we put this in, let's see. If we put this in our example here, now if I drag this over to 12, you see that it shows 12 AM. Now I can go through all the times, and when it hits noon, it goes to 12 PM. So you can see here that this is 12 here, and it's 0 here. So now I can account for all the times. And you can also do this for, like if you have an original appointment time, or then you have like an offset time, if you have to add hours, you can use the string function to grab the left function to just grab the hour, and then you can add whatever difference there is. So like, let's say somebody's appointment was 5 hours ahead or 5 hours behind, you could +5 or -5, and then you can rebuild the time. And I've shown a demo of that before, but this way you could do it where it accounts for the change in time. So if somebody had for example, if somebody had an appointment at 6 o'clock, like 6 o'clock, and they added 5 hours, that's going to roll over to the next day. So 6 p.m. or sorry, if it's more than 5 hours. So like, let's say it's 8 hours. So 6 p.m. it's going to be midnight, and then 2 more hours after that it's going to be 2 a.m. But you're going to have to account for that and the next day. So it's going to roll over to the next day. And you can use that. You won't really need the mod function specifically for that, but the mod function would help if you have, if you're doing a 12-hour clock. Because the nice thing about REDCap with the 24-hour time is that it's a 24-hour clock, so you don't have to worry about AM or PM. Now, you would have to, you could use the mod in this fashion where REDCap basically caps out at 23:59. So if somebody had an appointment at 10 p.m. and you added 5 hours to that, it would be 27 o'clock, 2700, and you don't want that. So what you could do is you could use the mod and do, instead of base 12, you would do base 24. So that it'd be mod 24, and then it would wrap around to, 0200 or 0300, whatever I was whatever difference I had added. But you can see the point is that it would just roll over, and so you could use the mod function for that. And originally, when I had to do the date before the mod function, is whenever you divide something by 7, it has there's like decimal numbers afterwards, and those decimal numbers repeat depending on what fraction of 7 it is. So what I did was I just took, I had like a string function that said, give me the right 3 characters. And so like, for example, if I had like 25 divided by 7, it's going to be the 571. And so, and every one that's that, so 25, so that's 4 off of 7, because 21 goes into 7 3 times, or 7 goes into 21 3 times. So if you're 4 days off of that, anytime you're 4 days off of a week, it'll be 0.571. So I just had to do all those calculations and make sure I had all the decimal points correct, and then I just created a loop that went through all 7 numbers that I calculated, and that's how I did it before. But this would be much easier just doing it this way. Anybody have any questions on that? Or would like to see anything in the design?
That was pretty awesome.
Does it work for leap year?
Yeah, it should. Because it counts the day. The way because it's still counting it's just a date difference. So it doesn't matter if it's leap year or not. It's just however many days from this date forward to the second date that I pick. So it's going to account for that.
Cool.
Yeah, that's what's nice, is that you don't have to worry about how many days are in the month or anything like that. Even if we went, well into the future, it's always, because the nice thing is that no matter what your date is, you're just looping through the days of the week.